Discovering Alabama is a production of the Alabama Museum of Natural History.
The Alabama landscape has changed many times down through the Earth's history. Geological forces have been at work for ages, sculpting and shaping the surface of our world. From this continuous process of change has come the beautiful state we know today. Come along as we go for a brief trek through this wonderful terrain to learn of Alabama's immense journey through geological time. This program is about a land unknown to many people, a land that in many ways has escaped the hustle and bustle of modern civilization, a place with bountiful backcountry, forests, streams, and wildlife more diverse than can be found in much of the inhabited world. Come along with me as we explore the natural wonders of this land. Come along as we discover Alabama. Alabama is a land of surprising beauty and diversity, and the geological map of the state shows us the reason why. A great variety of geological regions, resources, and formations. Alabama contains nearly every major aspect of America's grand natural character. Mountains and prairies, rivers and forests, wild wetlands and white sand beaches, all blessed with many kinds of life. But Alabama hasn't always looked like it does today. Scientists say that around 5 billion years ago, the Earth was born from an angry cloud of primordial dust and gases. Later, as an atmosphere developed, some of these gases combined to form water, which rained down on the young planet for millions of years, making rivers flow and oceans fill, and crafting a blue, watery world unique among its siblings in our solar system. As the Earth has aged, the moving force of water has constantly sculpted its surface. Wherever mountains have risen, water has worn them down again. Wherever valleys have appeared, water has carried eroded sediments to fill them, thus shaping and reshaping the landscape time and again over the Earth's history. One layer of sediments comes to rest on top of another to create the layer cake design of the Earth's crust, where each layer may represent millions of years of time and change. So water, weather, and overall climate have played heavily in the development of the Earth and in the development of life. And if we look back over the millions and millions of years, there's an important landmark in the Earth's history, a point when life multiplies rapidly. Many new creatures come on the scene. Fossil evidence of animal life first becomes abundant from the oceans of the Cambrian period, around 500 to 600 million years ago.
For maybe 2 billion years prior to the beginning of the Cambrian period, there was locally abundant life in the seas. This life consisted of single-celled organisms such as bacteria, algae, and the like. However, at the beginning of the Cambrian period, a new phenomenon was occurring. These marine animals were able to produce on their exterior or interior shells or hard body parts through the metabolic processes of life. The skeletal and shell fragments of these animals form the fossils that we see today. Okay, practically no fossils for 9/10 of the Earth's history. And then, all of a sudden, a lot of fossils. What happened? A key factor was a developing atmosphere, which changed from its original mix of deadly gases to mainly carbon dioxide.
And that helped two important things to happen. First, as carbon dioxide became prevalent, plant life was able to increase. Plants take in carbon dioxide and give off oxygen. Second, the Earth's oceans dissolve carbon dioxide like sugar, where it combines with calcium to form calcium carbonate, a chief compound for shells and skeletal structures. And about 600 million years ago, there was enough available oxygen and calcium carbonate on Earth to allow a dramatic expansion of life. Fossils, then, are key evidence, a tangible record of the progression of life on Earth, preserved in the successive layers of the Earth's crust. Using this record, scientists have pieced together a linear sequence of geological periods, from the Cambrian, back when fossils first became abundant, up to the most recent, the Quaternary. These many periods span three broad eras. The oldest and longest era is the Paleozoic. During the early Paleozoic, very little land was visible on the Alabama landscape because ocean waters ebbed and flowed over most of the state. These oceans teemed with Paleozoic life. Over time, the remains of this life were deposited as limy sediments on the ocean floor. And today, this is what that ocean bottom looks like. After millions of years, the sediments became Alabama limestone. All of this is limestone, great layers of it. Limestone is the rock of nature's choice in forming caves, and thanks to an abundance of Paleozoic limestone, Alabama has thousands of caves, more than most other states. But you don't have to go caving to find Paleozoic age sediments. The highway cut through Birmingham's Red Mountain is one of the best exposures in the nation. Here, next to layers of limestone, we also see layers of iron ore. In the Paleozoic Sea, tiny particles of dissolved iron came in contact with certain bacteria that cause the iron to oxidize or rust. Over millions of years, these specks of rust accumulated on the ocean floor to create iron ore. Eventually, the early Paleozoic oceans receded, and much of Alabama emerged as open land, tidal pools, and marshes, a scene soon to be shaken by the brooding powers of the ever-restless earth. As volcanoes erupted in East Alabama, further west towards the center of the state, muddy rivers deposited huge amounts of sand and silt to form great swamps. Life became better adapted on land. Amphibians multiplied, the first reptiles appeared, and monstrous insects inhabited marshy jungles of giant ferns, horsetails, and club mosses. This coal seam is what's left of one of those boggy Paleozoic swamps. Much of the dead vegetation that falls into a swamp doesn't rot. It's transformed into a high carbon residue called peat. When the peat's compressed by layer after layer of overlying sediments, it's transformed into coal. Now you might be wondering why this coal seam, which was once a low swampy site, is up here in this hillside. Towards the end of the Paleozoic era, something happened that literally gave rise to much of the Alabama landscape. We may call it terra firma, firm earth, but the crust of the earth is composed of huge plates of land that are constantly moving. The rate of movement is only centimeters per year, but over geologic time, this has led to some earth-shaking events. About 300 million years ago, there was a great collision of land masses. Europe and Africa smashed against the Americas to form one huge continent called Pangaea. The collision pushed up the mountains of eastern Canada, New England, Pennsylvania, and beyond, on into North Alabama. Today, the mountains created by this continental collision are called the Appalachians. Alabama's Talladega Ranges are the southern terminus of this mountain chain. The state's highest peak, Cheaha, reaches roughly 2,500 feet. That's not high as mountains go, but when the Appalachians were created, it may have stood as high as Mount Everest does today. Here in the Appalachian region of the state, and in the adjoining region called the Piedmont, these mountain-building forces created unusually great heat and pressure within the earth. forces that helped to form other special features in the state. Here's a vein of quartzite. Early in the Paleozoic era, grains of sand drifted to the bottom of the sea and cemented themselves together to become sandstone. Later, under heat and pressure, the sandstone became quartz, which eroded, washed to the sea, where pulverized and refined, it became, that's right, the sands of Alabama's sugar white beaches. Sand, sandstone, quartz, and back to sand again. Sea bottoms rise up to become mountains, and mountains go back to the sea. On their way to the sea, the waters from mountainous North Alabama take a last tumbling plunge along a feature called the Fall Line, as we see here on the Cahaba River just upstream from the town of Centerville. This fall line runs all the way across the state and marks the southern edge of the rocky highland terrain pushed up by events in Paleozoic times. The Paleozoic era ended around 280 million years ago and was followed by an era that's prone to capture the imagination. The Mesozoic era was the time of the terrible lizards, the dinosaurs, and an age when reptiles ruled. There were hundreds of different kinds, from the tiny to the gigantic, flying, walking, and swimming. The Mesozoic era also saw the emergence of trees and flowering plants. In fact, this is a time when life appears to be well established on land. And again, the evidence suggests changes in the atmosphere. For a long time, the Earth was unprotected from the deadly ultraviolet rays of the sun. By the Mesozoic era, however, some of the now abundant oxygen in the atmosphere had formed a heavier gas called ozone. High up, a layer of ozone screened Earth from most of the ultraviolet radiation. Conditions are ever more inviting for life out of the water, out of hidden places, and out across the open land. And speaking of land, the early Mesozoic era saw the breakup of the supercontinent Pangaea. The African continent separated and began to drift east, while North America moved west. Meanwhile, the Appalachians continued to erode south into the East Gulf coastal plain, a region periodically covered by the seas of ages to follow. Sediments from these seas have given lower Alabama its own variety of distinctive geological features. And here, exposed along the banks of the Tombigbee River, we see another kind of limey sediment. It's called the Selma chalk. This outcrop is just the top of a formation that in places is 700 feet thick. And in this chalk are zillions of tiny marine creatures called coccoliths. And these are coccoliths. The dark earth of the Black Belt region lies atop the Selma chalk. Wherever these limey sediments are close to the surface, they retain water and decaying matter and create soils with a rich organic quality. Deeper formations from Mesozoic ocean environments are the source of substantial oil and gas deposits in Alabama. A little time spent exploring this region of the state, and you can stumble onto some of the best fossil sites in the world.
In places like this, in the coastal plain of Alabama, there's an abundance of fossil materials. A prime example, very characteristic of this part of the Black Prairie region of Alabama, is this oyster, which is extremely common in this particular site. Apparently this was a great place for oysters to live 65 to 80 million years ago. And we find several different kinds. Here is one completely different. But this one makes up probably 90% of the fossils you find in this particular locality, and there are literally tons of them here.
Among the reptiles of the Mesozoic age were great crocodile-like creatures called mosasaurs. One of the best mosasaur fossils ever found comes from Alabama. There's also fossil evidence of the Hadrosaurus, or duck-billed dinosaur, a water-feeding fellow with a duck-like bill used for spooning up various foods. Despite improving conditions for life on Earth during the Mesozoic era, The long reign of the dinosaurs ended quickly and mysteriously. And here along the banks of the Tombigbee River is a good place to find this. This is the last sediments from the age of the dinosaurs. Now, it may have taken weeks, months, or longer, but you might say this marks the day the dinosaurs died. Below this point is prairie chalk, the last of the Mesozoic formations. Above it is the Clayton Formation, the first layer of the Cenozoic Era. There are several theories for the demise of the dinosaurs: rampant disease, changing climatic conditions. A popular theory holds that a tremendous asteroid collided with the Earth, throwing up clouds of dust, blocking the sunlight, and bringing catastrophic change. Each step I take up this stratified surface, I step across millions of years. And here I stand with one foot in the Mesozoic Era and the other foot in the first sediments of the latest era of geologic time, the Cenozoic. This demarcation of sediments also means that Alabama's coastal plain is divided. In the upper part, the surface is mostly of Mesozoic age. The lower part, mostly of Cenozoic age. Throughout the Cenozoic, the last 65 million years, there was a periodic rise and fall in sea level. At times, Alabama's coastline was much further south of its present location, and at times, further inland.
The coast is constantly changing over geologic time. The present shoreline was probably established within the past few hundred years. This ridge we see right back here is a remnant shoreline of the past few thousand years. And if we continued inland across the coastal plain, we would find recurring evidence of ancient shorelines, seabeds, and of course life that inhabited those Cenozoic marine environments going back 30, 40, 50 million years ago.
Here we are better than 60 miles inland, near the town of Jackson, Alabama. This high bank here is largely composed of marine fossils from Cenozoic times. Here we go. Several shark's teeth, the spiral shell of Turritella, and the rib shell of Venericardia. The Cenozoic Era was also a time when plants continued to advance, accompanied by many new animal species, including birds and mammals. Later periods of the Cenozoic gave rise to large herbivores like the woolly mammoth and fierce carnivores like the saber-toothed tiger, who were still around when Mother Nature pulled a chilling surprise, the Ice Ages. About 2 million years ago, the global temperature dropped severely, causing the Arctic ice cap to alternately expand and thaw. The ice itself never reached Alabama, but corresponding fluctuations in weather and sea level did add some finishing touches to the terrain we see today. By the end of the Ice Age, about 10,000 years ago, the landscape of Alabama had developed most of its present natural features. From the steep hills and hollows up near the Tennessee Valley, through the rolling country of the coastal plain, and down to the expansive wetlands of the Mobile Delta, Alabama's landscape bears memory of the many earth-shaping events across the eras of geologic time. And into this land had come a new inhabitant, Homo sapiens.
I'm probably not the first person to sit in this site and try to make a tool out of a piece of native rock. This bluff shelter and this material represents man's adaptations to what nature has provided. And the people who survived were the people then who could deal effectively with this environment. They could use this cave to advantage. They could use the rivers to advantage. They knew there were fruits and berries in the woods certain times a year. They used those to advantage. And people who didn't know how to do that didn't stay around long. So It all comes back then to sort of civilization and geologic consent, whether you're talking about it in a bluff cave that technically was not civilization, but where the resources are, whether it be oil or gas or iron ore or limestone or coal, then depends what human beings can do in those places. If you don't have those resources, then what you can do in building your society is limited.
In barely a microsecond of geologic time, the woolly mammoth and the saber-toothed tiger would be replaced by the buffalo and the eagle, and the first human inhabitants would give way to various tribes of native Indians. Soon new settlers would arrive, building towns along the fall line to use the water power for their mills, establishing farms in the Black Belt to use the rich soils for their crops. Quickly they would learn to use limestone for making cement, iron for tools, and Alabama's coal, oil, and gas to fuel engines of progress. There grew to be hundreds of new uses of geological resources, supplying almost every major need. It happened in the blink of an eye. Over the Alabama landscape looms the shadow of the modern age.
We wouldn't be where we are today if it were not for the development of our geological resources. However, if we want to get much further than we are today, we've got to be mindful of the effects of human activities on our environment. For instance, we are releasing large quantities of chemical pollutants into the atmosphere that's resulting in depletion of the ozone layer. It's probable that the burning of fossil fuels is adding to the increase in the carbon dioxide content of the atmosphere and the resulting increase in average annual temperature of the Earth, in other words, the greenhouse effect. The net effect is that in only a few hundred years, man has greatly stressed his environment, and this stress is increasing rather than decreasing.
Okay, here we are back at the top of this glorious mountain country. As we've seen, to understand the geological history of the Earth, we have to look at physics, biology, and chemistry, all interacting together to give us this unique life-supporting environment. Today we realize that the rapid growth of human society brings accelerating change to our special planet. And now we need to look also at how government, economic development, and science can better work together for the future of our world. And this includes the science of geology. All in all, the geological history of our world is quite a story. Some may have difficulty accepting this story or the science of geology and the answers it provides. Well, think about this. In addition to the questions of what happened, when, and how, a real big question is why. And here I think we all can agree. The geological wonders of Alabama can stir the soul with a profound sense of awe and inspiration. Due to technical limitations, we were obliged to bring you the story of Alabama's 5 billion year history in only 30 minutes. We hope you enjoyed our abbreviated version. Please send any comments to Discovering Alabama, Alabama Museum of Natural History, P.O. Box 870340, University of Alabama, Tuscaloosa, Alabama 35487.
Funding for Discovering Alabama is provided by the Geological Survey of Alabama, Gulf States Paper Corporation, the Lynn Henley Trust, the John Alside and Delia Truss Robert Charitable Trust, and the Alabama Forest Resources Center, promoting education and cooperation for all the benefits of proper forest management.